Okay, before we talk about volume and what it is, I want to mention about the units that you're going to use. Units for measuring volume include milliliters. You could use that for liquids. You look on a can of soda, it tells you how many milliliters of water or drink is in there, or any kind of bottle, like water bottles. They tell you how many milliliters of water is in there. The other unit you're going to see for volume is cubic centimeters, cubic meters. You're going to see cubic something with a little 3 next to it. And that usually pertains to solids or gases, but we're not going to be measuring gases. That's a little bit hard for us to do. Just remember that solids, they need to be cubed because you're going to be looking at not a liquid. Now, when we were looking at the water last week, many of you found out that your 50 milliliters of water came out to about 50 grams. You found out that a milliliter of water is almost equal to a gram of water. And another thing you should know is that 1 milliliter of water is also equal to that. Okay? Now let's get on with what volume is. Okay, today we're going to talk about how to measure the volume of something. Volume is how much space something takes up. How much space something takes up. Whether it's liquid or solid or a gas, it has volume. It takes up space. And that is something that you can measure. Now in class, you're going to be measuring the volume of liquids and solids. And measuring the volume of liquids is probably the easiest thing. Liquids, when you measure the volume of that, you can just use a graduated cylinder. Cylinder. Remember those things we used last week? The tall things. It had a whole bunch of lines on it. You just put the liquid in there, and then whatever number it goes up to, you measure that number, whatever it is, in milliliters. Okay? And if you need to convert it to liters, then you can just do that by moving the decimal point. So, take a look at that picture there. Somebody put some water in the graduated cylinder on the left. Went up to about 20 milliliters. And then they put a rock or whatever into the water. And then it went up to about 23 milliliters, it looks like. So that means the volume of the rock is 3 milliliters. You subtract. You subtract whatever that number is and that number. You subtract those two numbers and you get the volume, the amount of space that that rock took up. Okay, and that's usually in milliliters. That's the way to get the volume of an irregular shape. But if you're just talking about liquids themselves, then just put the water or the liquid in the graduated cylinder, and that's your volume of the liquid. And this is taking the volume of an irregular shape using the liquid. Let's talk about another way to take the volume of something. Regular shapes. and you have to go length times width times height. Length times width times height. L times W times H. People who work at UPS, FedEx, USPS, the postal office, they're always wanting to know the package sizes. You know, how big is the box you're trying to ship? They take up space in their trucks, so they need to know how many boxes they can put in their trucks, so they can use a mathematical formula to figure out, okay, well, we can take so many boxes, and we got to pay for gas, and we got to pay the guy driving the truck. So they use this mathematical formula to figure out, okay, we need to charge the people so many dollars to ship a box. So, of course, smaller boxes cost less than the bigger boxes. So that's how they need to know, that's why they need to know the volume of the boxes. It costs money to ship them. So to measure the volume of a box, or any other kind of, regular shape, something that has a length, width, and height, you're going to use a ruler. It's like a meter stick. So if you take the length, okay, this one's about 5.9 centimeters. Notice the box doesn't go quite to the 6. It's like a little line before it. So that means it's 5.9 centimeters. That's its length. That's the longest side. So then you got to measure the width. So, okay, let's see. Let's turn it this way. And it's about 2.7. Looks like about 2.7, 2.8. So you got to go where the line is here, that's the 2, and then you got to count those little tiny lines past, because it's certainly not 3 centimeters, it doesn't go all the way to the 3. And it's past the 2. So you count those little tiny lines, and to me it looks like about 2.8. Now remember, a box has a length, a width, and then a height. And if it's got a perfectly square shape like that, well then that means two sides are probably going to be the same. One is the length, one is the width, and one is the height. See that? One is the width, one is the height, and that's the length. Okay? 2.8. So you can just take your calculators and you can calculate that all out, come out with an answer, and whatever that answer, that number is, the answer will be some number in centimeters cubed, because this is a centimeter, this is a centimeter, and that's a centimeter. So you're taking 3 numbers, you're multiplying them together, so your answer is going to be cubic centimeters. Little 3 right there, that's an exponent. Goes up high, not right next to the M, but just like above it a little bit. Okay? So the other way to measure volume is called displacement. And you have to go back to using a graduated cylinder, or you can use an overflow can. So remember this picture. This is water displacement. You're still having to measure the volume of a liquid because you got to start off with some amount of water. Okay? Up here, it was just we want to know the volume of the liquid. So like last week, you had to measure out 50 milliliters of water in a graduated cylinder. The 50 milliliters was its volume. Then you had to stick it on the triple beam balance and get its mass. Okay, this is volume now. We want to know how much liquid is in there. So if it's something strange like a rock or some other object that has an unusual shape, you can do this. You can stick it in some water and see how much the water goes up. Okay? But let's say you have an object that doesn't fit in the graduated cylinder because, you know, they're kind of skinny, so that kind of limits what you can put in there. Then you can use these things. We have these, and you'll be using these. They're called overflow cans. And they have a spout that comes out of them. And you put a bunch of water in it until the water starts coming out of the spout. And then you just let it sit there and stop dribbling. And then once it stops dribbling, you go ahead and put your object in the water. And as, of course, you know, the rock or whatever it is that you're putting in there, this item, is going to make more water come out because it takes up space. It has volume. So that water that comes out, you're going to catch. You can catch it in a graduated cylinder and then measure right then and there. 20 milliliters of water came out. That must mean the volume of that object had 20 milliliters. Or you can just catch it in some other container and then go pour it in your graduated cylinders to figure out exactly how much water came out. But that's what you need to do with displacement. The volume, the space that some object is taking up, is making that water get out of the way. It's displacing it, and you can either measure it by this method, put some water in, know how much, put the object in, see how much it goes up by. How much it goes up by is how much volume that item has. Or you can do it like this for larger objects that will fit in an overflow can. You fill it up until the water comes out. Then you put your object in there and you catch the stuff that comes out. Because the stuff that comes out is the water that is being displaced, getting out of the way for that item. Whatever comes out is your volume. So you have to catch that stuff and go measure it. And that's what you're going to be doing in class. You're going to be using all three methods of measuring volume. Okay? So when you get an item, you got to know, okay, here's a box. Which method should I use? I don't think it will fit in the graduated cylinder. You could try putting it in the overflow can, but this method would be better for that. Length times width times height. Okay? If you get something unusual shaped, like this, it looks like it's a cube, but it's not perfectly straight. It's more like a parallelogram. So maybe using a graduated cylinder would be better, or you could try using the overflow can. You're just going to have to figure out which method would be easiest to use based on looking at the items that your group gets. Okay? See you in class.